Hello viewers, this is Kavita Giri, PGT Maths KV Silchar. We are going to see straight lines which is in class 11th. Let's begin. All the concepts of straight lines we are going to see. The first concept is slope of a line. How do we define a slope of a line? A line in a coordinate plane forms two angles with the x-axis which are supplementary. You can see here that in this diagram we have x-axis and this is the line. Line is making an angle theta with the x-axis. And when we know this angle, at what angle this line is inclined to the x-axis, if we find tan theta, then we will get the slope of the line. So the slope of the line is given by tan theta, where theta is the angle made by the line with the x-axis. Now we have slope of a line when coordinates of any 2 points are given. Let us take 2 points. One is x1, y1 and the other coordinates are x2, y2. These are the coordinates of 2 points on a line. Then its slope is given by m. This m shows, m is representing the slope of a line. So how do we find the slope of the line? The formula is this: y2 minus y1 upon x2 minus x1. The next is, how do we know? By looking at the equations of the line whether they are parallel or perpendicular. So we are going to see conditions for parallelism and perpendicularity. If two lines have the slope m1 and m2 and we have to see whether they are parallel or not, we have to judge m1 and m2. If m1 is equal to m2, then the lines are parallel. But when they will be perpendicular, if the product of the two slopes m1 into m2 is equal to minus 1, then the lines will be perpendicular. So we can very easily judge by looking at the equation of the line. If their slopes are same, they are parallel. If their slopes product is minus 1, they are perpendicular. Now let us have a look at various forms of equations of a line. The first is horizontal lines. Horizontal lines means a line which is parallel to x-axis is a horizontal line. So its equation is given by y is equal to constant. And what are vertical lines? The lines which are parallel to y-axis. So the equation is x is equal to constant. The next is point slope form. If a line has a slope m and it passes through the point x1, y1. As the name suggests, point slope form. There must be point, there must be slope. These two things should be given. So point here given is x1, y1 and the slope given is m. So what will be the equation? Y minus y1 is equal to m into x minus x1. Here m is the slope and x1, y1 are the coordinates of the given point. And what are x and y? They are the coordinates of a general point. The next is 2-point form. 2-point form. Well, let the 2 points be x1, y1 and x2, y2. Then the equation will be given by y minus y1 is equal to y2 minus y1 upon x2 minus x1. You have already seen what does this quantity represent. Let's go back to that slide. Then you will know again. M is equal to y2 minus y1 upon x2 minus x1. This gives you the slope of the line, isn't it? This gives you slope. So when we have 2 points given on the line, then its equation can be written as y minus y1 is equal to slope into x minus x1. Look at the previous slide. Y minus y1 is equal to slope into x minus x1. So this is y minus y1 is equal to m into x minus x1. So that m we have found here by the 2 points, y2 minus y1 upon x2 minus x1. The next form is slope-intercept form. There are two cases when, see, as the name suggests again, slope-intercept. These two quantities must be given for the line whose equation is to be found, slope and intercept. So there are two cases. One, let's see the case 1. Suppose line has a slope m and it crosses y-axis at a point 0, c. The line crosses y-axis at the point 0, c. That means line has y-intercept c. Then its equation is given by y is equal to mx plus c. Let us see the next case. The next case is if the line has a slope m and has x-intercept d. Now what do we mean by x-intercept d? Means the line will cross the x-axis at the point d, 0. Then the equation will be given by y is equal to m into x minus d. Here m is the slope and d is the x-intercept. Now intercept form. Now what is the difference? There we were given slope and intercept, these two quantities. Now in this situation we will be knowing the two intercepts together, x-intercept as well as y-intercept. If a line makes x-intercept A and y-intercept B, then its equation will be given by x upon A plus y upon B is equal to 1. Now what is x upon A? What is A? It's the x-intercept. So x upon x-intercept plus y upon y-intercept is equal to 1. The next form is the normal form. Suppose a non-vertical line is known to us with following data. What are the data given? The data are that length of perpendicular from origin. Line is there and its distance from the origin is given as p. And that normal makes omega angle with the x-axis. Then its equation is given by x cos omega plus y sin omega is equal to p. This is the equation. Now as we all already know, ax plus by plus c is equal to 0 is a linear equation in two variables. And this represents a line. We have already seen the graph of ax plus by plus c is equal to 0 in class 10. Now we can reduce this general equation into various forms. The first form is slope intercept form. Y is equal to minus a by bx minus c by b. Here minus a by b is the slope of the line and minus c by b is the intercept of the line. Next is if c is not equal to 0, we can convert ax plus by plus c is equal to 0 in the intercept form. See how we have converted. Firstly, we have taken minus c to the other side. Then we have divided both sides by minus c to get 1 on the RHS, because in the intercept form we have x by a plus y by b is equal to 1. Here we should have 1. So we will divide both sides by minus c. Then we get ax upon minus c plus by upon minus c is equal to 1. Then divide that a, bring that a in the denominator and bring that b in the denominator. So we get the x-intercept as minus c by a and y-intercept as minus c by b. This is how we convert the equation in the intercept form. The next is the normal form. How we convert it? You can see you have to divide the whole equation by square root of a square plus b square. And then we have a upon under root a square plus b square as cos omega, b upon under root a square plus b square as sin omega, and c upon under root a square plus b square is equal to p. So it's very easy to convert the equation in the normal form. Just divide the whole equation by under root of a square plus b square. Now the next concept in the chapter is distance of a point from a line. Now there must be a point, there must be a line. Let the line is ax plus by plus c is equal to 0 and the point is x1 y1. We have to find the distance between the two. So the formula is given by d is equal to modulus of, that is positive value of ax1 plus by1 plus c upon square root of a square plus b square. Then what we have to do, the simple trick is in place of x and y you have to put x1 and y1. So it will be like ax1 plus by1 plus c divided by square root of the coefficient of x square plus the coefficient of y square. Now we have to see distance between two parallel lines. If the lines given are of the form y is equal to mx plus c1 and y is equal to mx plus c2. Now you must be wondering, if two different lines, then it should be y is equal to m1x plus c1 and y is equal to m2x plus c2. But m1 and m2 are not specified, they are only m, because the lines are parallel. We know for parallel lines their slopes should be same. That is why both are same, m and m, represented by the same alphabet and same notation, m. So if we want to find the distance between these two, the formula is d is equal to modulus of c1 minus c2 upon square root of a square plus b square. Thank you everyone.